Okay, so members, today we are going to see a new topic called conic section. Conic section includes basically 3 to 4 things. We have what we call parabolas, we have ellipses, then we have hyperbolas, and also some people consider also circle to be a conic. Now, we are going to handle one by one, but all these are rotating about one thing, what we call eccentricity. Now, if eccentricity is 1, then the conic we have is what we call a parabola. Now, how do we define a parabola? A parabola is a locus which moves, this is a locus which moves such that its distance, so that the ratio of its distance from a fixed point, this point is fixed, to its distance from a fixed line. Now this fixed line is what we call the vertex. This fixed point is what we call the focus. The ratio of this distance to this distance is 1. So that's how we define a parabola. Now let us see how we derive the equation of a parabola. Now you see that this one, its vertex is at 0, 0. So some people call it the standard one at 0, 0. Now, how do we define that? Now, when we look at this, you see that now we have said that the ratio of its distance from a fixed point, PF, to its distance from a fixed line, this line is fixed, is equal to the eccentricity. But now, if the eccentricity is 1, that's when we have a parabola. So if this E is 1, then if I cross multiply here, I have this equaling to this. Now, I can get the distance PF. If I'm to get distance PF, I'll say this point from this point, I'll say x minus a squared, then plus y minus this. Get that. Then PM, it's here from PM. Now, to get this point, you start this point is from here up to here, it's having the same value of y. That's why if this is y, this is y. The value of x, because it's on this line, every value of x here is negative a. That's how we got to that point. And this is PM, I say now x minus x coordinate, but remember this one is negative. Give us now the minus, then we square, then plus y minus y, which we have there. Now that if I square this side, I also square this side. Why do I square? To remove the square root. So if we square, so what we generate is, if I square this, I'll be having this only. But y minus 0 is y. But remember, we are squaring it. Then x minus, that's why we have a positive here. Then y minus y, that one is a 0. Then if we expand this, we have this. Then this is there. If we expand this, we have this, and that. Now we see that from there, this one is going to cancel. Then this a is also going to vanish. So that we are surviving with this y, which is here. When I take this negative 2ax, this side, it will be now 2ax plus 2ax, which will give me a 4ax. And this one is what we call the equation of a parabola with its vertex at the origin. Now, the coordinates of the focus are, focus, vertex, and ellipse are, the focus for this is always at A0, then the vertex is at 0, 0, then the directrix is this line, x equaling to negative 1. Now, we want to determine what if we don't have a parabola, what if we have a parabola that is not at the origin, how do we get it straight? Now we consider, we are sure that now the vertex has shifted 8 units from the origin. This is our origin, remember this is our origin, and it has shifted also k units in y, meaning now the new vertex is here. Now if I shift this 8 units in x, it means that even this is going to be shifted 8 units. So always the vertex and the focus lie on the same horizontal line. So now you see this horizontal line, when I shift the vertex, even this focus is going to be shifted. So if I shift this with x, 8 units in x, even this one is going to be shifted h units in x. So the same line, start the same line. So if this is k, even this one is going to be k, because we say the focus and the vertex always lie in the same horizontal line. So if this is k, this one is going to be also k. Now what about the directrix? Remember, if I shift this h units, even the directrix is going to be shifted h units. So if I add the h units here, this is what I have. I have this plus h, which is that in there. Now, if that is the case, what is the equation of that general? The general equation is, remember in y, we shifted k units in direction of y, then square. Then direction of x, this one is constant. The direction of x, we shifted it with h units. So that's why we have that. And this one is a general form of a parabola with its vertex anywhere in the Cartesian. Now, its focus is here defined from here. Then the vertex we say is at hk. Then the directrix we say is x equaling to h minus a. Now, is this the only form of a parabola? No, there are other forms like this. When now we shift it, y squared will be negative when it's this side. Now the directrix, it's always opposite. So it will be now the side is a. When we have now this one, when this is the form, now our directrix will be in y. In y, whenever we're on y-axis, we use b, not a. For me, I use b to simplify so that I can differentiate them. Whenever we're on y, whenever we're on x, I use a. Whenever we're on y, I use this. So that even the b is going to be replaced. Now we have another when x squared is equal to negative. So you see that? Now this is the case and this is b y equal to b. So remember, that's a small introduction to parabolas. Now we are going to see how do we sketch them, how do we get the directrix, how do we get the vertex in the second lesson. I wish you the best. Don't forget to subscribe to our channel. I signed out.